Hello, my name is Alan. We are from Group 4. So today we will be presenting the binary search tree. Our group team is student management. So my group member is Azura Fidaus bin Azmi and then Kunawati and Perempuan Subramaniam. So this is for the assignment 1 task 2 for advanced data structure and algorithm. First, what is BST? So BST is a type of binary tree data structure in which each node contains a unique key and satisfies a specific ordering property. So all nodes in the left subtree of a node contain values strictly less than the node's value. So all nodes in the right subtree of a node contain values strictly greater than the node's value. So this structure enables efficient operations for searching, insertion, and deletion of elements, especially when the tree remains balanced. So hi everyone and doctor, my name is Ana Nushada binti Muhammad Zamri and I will be presenting BST based for student management system. So this is the table of contents for my part, my system. So we have system overview, the core node, key function insert, search, delete, the system demo, and then improvement for the next draft. So for the system overview, the objective is to develop an efficient cost-based system, which is C++ will be using terminal for the output. So this system is for managing student records, and then the system employs a binary search tree (BST) implemented in C++. So the key features. So for add, it captures student ID and course code, which is the primary key, and then search, which is instant lookup via student ID and the course code as well, and then display, which is auto sorted alphabetical student list and course code in a table view. And then when we remove withdrawn or graduated students from the system or remove unavailable course code. So why BST? So BST is efficient, so for faster search and insert by O log n and linear arrays, which is ON. So for the scalability, dynamic memory allocation pointer allows unlimited student record, which is will be growth year by year. So the first part is the core node. So we have start student. So the data is the student object. So the left pointer point to a smaller alphabetical, where right pointer larger alphabetical. So the sorting logic is tree straightly organized by the student ID. So as I mentioned, parent in the middle, left side is for the smaller, the right side is for the larger. So you can see for the example here. So this is the student ID we have S005, S001, S009. That is for the example. Next, the core node for the course, track course. So data is the course object, sorry. And then for the left pointer with smaller alphabetical course code. So larger side will be the right pointer. So what the alphabetical means? So we have, let's say, MECS. So and then we have MECB. So MECB will going to be the right side because it is larger than MECA. So we have here for the example of the sorting logic. So smaller suffix is MECA 2023 and the larger suffix is MECS. So let's say MEBA. So MEB is smaller than MECA. And then key function insert for student. So we have the logic by recursive comparison. So if the tree is empty, we create the root. So if the new student ID is smaller than the current, so we recurse left. So otherwise, the student ID larger than the current node, so it recurs right. So the duplicate student IDs reflect errors to prevent data duplicate, corruption. So we can see here in the code which is mentioned, the student ID already exists. Same goes insert function for the course code. Similar logic, similar flow, and then if the course already existed, it will appear error message which is course already exists as shown in the code above. Next, the key functions search for student. So binary search principle. So we check if the current node match the student ID. If not, we eliminate half of the tree instantly by choosing to go only left or only right. So we can see the coding here. Similar searching logic goes to the course code as well. Okay, now let's look at the delete function. So also called the remove internal. So this is the delete function at the student part. So how it works in a binary search tree. So when we delete a node, our main goal is to make sure the tree stays sorted. To do that, the delete logic handles three different cases depending on how many children the node has. So we have the flow here, flow 1, 2, 3. So it means case 1, 2, 3. So case 1, the node is a leaf. So if the node we want to delete has no children, so this is the simplest case. We just remove it directly because the thing doesn't affect any of other part of the tree. So case 2, let's say have one child, and then we can't just delete it because that would disconnect the whole subtree. So instead we bypass the node, meaning we link the parent directly to the node's child. So the node gets removed and each child slices up to take its place. So the last part is number 3, in case they have two children. So this is the most complex case. So when the node has two children, we need to keep the binary search tree property intact. The tree kept intact. So the standard way to do that is to replace the node's value with its in order successor, which is simply the smallest value in its right subtree. And then after copying the value over, we then delete the successor node, which is guaranteed to fall into one of the easier cases. So overall, the delete function maintains the sorted structure of the tree by handling each of these three cases appropriately. So this is the key function delete for the course code. So the logic is the same as the student ID. Hi everyone, Dr. So right now I will do the system demo only, as I already explained the part functionalities in the previously. So uh, next, I would like to sorry to Doctor, because right now my Visual Studio Code having some problem. So I'll do the system demo here inside the online compiler. So we'll run the system now. So tada, this is the system main menu, which is UTM, Student Management System. So we have three parts here, which is first student details, which means the student section, display, add, insert, delete, and then course details means course section, add course, view course, delete course, and then exit the terminal, the number 3. So let's go through the student details. So we have add student, search student, display all student, delete student, and back to the main menu. So we'll do the add student first. So we have enter student ID. So let's say S202. So we need to put name. So let's say Najiha. So enter the department, which is Department of Computing as me. So as me. And then GPA, let's say 3.5. And then year level, let's say year 3. Same as me. So it mentioned here, student added successfully. So we like to check whether the student detail inside the table or not. So we choose number 3, which is display all students. So yes, we can see here, which is some of the name is my group member, Azmi, Alia, and then Guna. So this is their department, GPA, and year. So, and then we like to add another student. Let's say we like to check if we enter one of the student ID here, what will happen. So let's say we enter Najiha ID S202, and then enter the name, let's say Amirul, and then their department, let's say civil engineering, and then GPA, let's say 3.66, and then let's say year level, year 1, let's say. So it mentioned here error, student with ID already exists. So because S202 is belongs to Najiha. Next, we have here to add another student, because we would like to add student just now. And then let's say we enter others number X604, let's say. So enter name Amirul, enter the department civil, CGPA 3.66, and then enter year level, which is level year 1. So student added successfully. So check again whether inside the table or not. Display of students. So we can see here Amirul is under Guna, because this number, this student ID is larger than S505. So we like to delete student. Let's say we would like to delete Najiha. So we delete S202. So we check again whether delete complete as mentioned here. We check again. 3. Oh no, yeah, 3. Display all students. Yes, so Najah is no longer inside the table. So we're going back to main menu, which is number 5. Back to main menu. So let's check the cost section, cost data section. So number 2, this is the main menu. So we check number 2, and then let's display all courses, which is the preloaded data. So here is the course code, course name, and credit. So here the course code is the unique ID, so which is the primary key. So let's say we would like to add course, and then let's say the course is MECA 2025. Enter the course name, let's say advanced AI, with the credit hours 5. So it mentioned here course added successfully. So we like to check whether inside the table or not. So display of course here. So in the character, A is come first, then R. So let's say we like to add another course with the same code. What will happen? With the same course code, what will happen? So MECA 2025, and then we add the course name, which is, let's say, another course name, which is, we can have advanced, no, not advanced, advanced computer science. We have that, right? A1 computer science, and then credit hours, let's say 5 also. So we cannot add the course because the course code with this course code already exists. So, and then we check what will happen to the table. So it stay the same as previous. So next we add another course, which is MECB2032. Let's say like that. And then we add the course name, which is what we have, pen test, penetration testing subject, pen test, and then credit hour, let's say 2. So course added successfully. So we check this pair of course. Yes, so the character B came second, then A. So pen test in the second line. So let's say we want to delete course. So number 3, delete course. Let's say we want to delete advanced AI. So MECA 2025. So it mentioned course deleted. We can check again the table whether deleted or not. Yeah, so course advanced AI is no longer in the table. So that's all. Going back to the main menu. So that's the student management system. That's all. Thank you. So for the next draft, for the task 3 assignment 2, so and then before the final submission, I will try to complete the coding inside Visual Studio Code and write in my own terminal instead of the online compiler. So and then beside that, the main important parts, maybe in the next draft, we can improve by the GPA alerts, where uh, students with GPA below than 2 can have warnings in the academy dashboard, because as we know, below than that usually will be removed from the university and cannot take any semester. And then we have file persistent, which is implement save the file or load from file, so the data can be retrieved or uploaded and is not lost when the console is closed. And then lastly is department grouping, so we can add category grouping to view student by department. For example, we have just now computing, so we can list out all of the students under the computing department faculty. Next, I will pass this presentation to Guna.
Hello and welcome. I'm Gunavati daughter Subramaniam and my matrix number is MEC255025. Here the presentation of MECS1023, which is Advanced Data Structure and Algorithm. Today I'll be presenting my solution 1 for the cost registration system, where I implemented a binary search tree or BST to improve the searching functionality. This system simulates a simple course registration platform that students can use to search and register for courses. At the same time, the admin can manage the courses information. This main focus of the solution is how the data structure, especially the BST, are implemented or applied to optimize the search operation. Here is the outline of what I will cover in this presentation. I will begin with an introduction to solution 1 and then explain how the login and role-based work. Then I will discuss the admin cost management features and show how the BST is used for cost searching. Then I will walk through the student registration process and demonstrate the working system. Finally, I will highlight the limitation of the BST in this solution 1, present my benchmarking plan, and explain the improvement I will implement in solution 2 using a big tree. Okay. Introduction to Solution 1. Solution 1 focuses on the building a functional cost registration system with the essential features. The system supports two different users roles, admin and student. The most important technical aspect is that cost searching is implemented using a binary search tree to provide a better efficiency than a simple list searching. Okay, this system is designed with several key functions. First, we have role-based access control that ensures only authorized users access these respective features. Admin users can add, edit, and delete the courses. Students can search for courses using the BSD and then register the course or remove their registered course if they don't want. All these operations are connected to MySQL for data storage. Here the admin, how I connect the database. Second, in this solution, the binary search tree is used to store the list of courses. Courses are inserted into the BST by course code. BST helps in faster searching because instead of scanning all the courses, the tree navigates left and right based on alphabetical comparisons. This reduces the search time significantly, especially when the number of courses are increases. The operation here include BST insert and also the BST search. Okay, now login and role-based access. The system starts with a login page where both admin and student use their username and password. After logging, the system checks the user's role. If the user is an admin, it directs to the admin dashboard. And if the user is a student, it directs to the student dashboard. This ensures proper access control and separate admin functionalities and student functionalities. Here, for example, how the login of the system. System architecture. This slide presents the architecture of this system. The front end is built using HTML, CSS, and PHP, while the backend uses MySQL as the database. BST operates at the application layer. When the students search for a course, instead of scanning through all records, the BST structure quickly locates the matching code. This improves the system performance and responsiveness. Here, the PHP admin for that. Next, the admin cost management. The features everything. The admin dashboard provides full control over the course database. Admin can add new courses by entering the course code and course name. They can also edit existing courses in case of name changes or code updates. Admin can delete the courses that are no longer offered also. Additionally, the system displays the total number of students registered in each course, which is calculated using a relational join with the registration table. These features ensure that the course list remains updated and very clean. One of the strengths of this system is that course searching and registration are linked in a single flow. Once the student finds a course using BST, the system allows instant registration with just one click. This makes user experience very smooth and intuitive. Now, the implementation of a course search. The BST is implemented using PHP classes. When the system loads, the course code from the database are inserted into the BST. This makes the search process fast instead of comparing with the every record. BST navigate node by node. It balancing tree, the time complexity is 0 log n, which is a huge improvement compared to 0 n, which is now. And normally searching. This is the core data structure used in the solution 1. Next, student registration process. The student registration process. This is a flow, is a simple, user-friendly. Students start by searching for course code using the course code. If the course exists in the BST, the system displays the details immediately. The student can then click the register button to add the course to their registration list. All the registration data is stored in that MySQL database. Student can also view all the courses and they have registered for, and if needed, they can delete a course from their list. This deletion function updates and database and refresh the interface in a real time. Okay, now I will explain the system demo. The demo starts with logging in using the credentials. Next, the student navigates the search page and uses the BST search box. After searching, the students register for the selected course. The registered course appears in the table at the bottom of the page. Similarly, deleting a course immediately updates the registration table. Okay, for now, on the admin side, demonstrate the adding, editing, and deleting courses as well as viewing the number of students registered. And this is proof that the core features of the solution 1 is working correctly. Now, I want to show the demo for the admin page.
Page demo. So in that, okay, here I log in the main dashboard for the admin page. Here the manage courses, which you want to add this. And here this is already the courses that the admin added. If not, this example, I say C2311. The course name, maybe it will write like naming. Okay. Add that course. And then here the course already added in the list, which is with the sort list. Okay, if I want to edit, I click the edit button and here I change the code to 3. And then machine learning, maybe I add 2. And I click update. And it will change the code and the name also. If I don't want that, and then I can delete it. If I select OK, the pass will be deleted here. And here the student registered, now there's no anything, the last number is already, everything is 0 here. And now we see the courses, okay, this is the number, again I add, and then I add here the name, so I add course, and here already added, and now check in the MySQL database, okay, and under the courses. So the machine learning subject is already added in the database here, and the course the admin already stored in the database of the course registration system using the SQL. And here the logbook update, and if I delete one that, okay, if I delete, okay, and then here I select again, so the course that I deleted already removed from the database. And here if I can log out from the admin dashboard.
Okay, now I will show the student demo, which means the student dashboard, how it works.
Here I show how the student portal will work. Here I'm logging as a student. For example, I log in as a student 1, and then I enter the password. Then log in, and here the dashboard for the student, and then click the course registration, and here will be the dashboard will display. Here already I just tried before to add course. Okay, now I add one more course. For example, if I select I want to use the capital letters only because of the BSD search. So here I select MECS, which is the research strategy, and here I click the register, and here I'll display the 3 courses that registered by this student 1. And then now I want to show how it will be saved in the database at MySQL. For example, here now I want to enter the query for how many courses that registered by this student 1. The name, then is the student usually example one is ready. Okay, student have registered 3 courses. Okay, now I want to display how many courses have displayed the but now I want to know what are the 3 courses that student 1 added. I want to add the query for it. For example, select okay, register the student username course name. This is equal to CID. Our student from Tanzania. Then now actually here we show the student 1 have 3 course code registered with the course name. Here and here with the same thing. So the database has the same data that student 1 registered. Thank you.
Okay, next is here the code that I'm using for the BST PHP. Now the BST limited in the solution 1. Although BST improve our performance, it also has a limitation. If the courses are inserted in a sorted order, the BST can become an unbalanced and behave like a linked list. In that case, the search of operation degrade to 0 line. Also, BST require exact course code matching. Students cannot search using partial course codes and keywords. These issues directly affect user experience. Students may experience slower search results if the tree becomes unbalanced. Also, requiring exact code makes it harder for students who do not remember the full course code. Maybe these limitations show that BST is not for the most ideal structure for the larger data sets. Okay, recommended solutions. To address these issues, I recommend moving to a self-balancing tree or a multi-way tree structure. A B tree offers a better balancing and provides more consistent search performance. Additionally, prefix search that filtering should be added to improve discoverability. The solution 2 will be replace BST with a B tree. A B tree keeps all nodes balanced and supports storing multiple keys in search node. This results in fewer levels and faster searching. It also handles the larger datasets efficiently, which is crucial for systems with many causes. Other improvements include a better UI and the enhanced navigation to take the system more modern and more friendly. The performance benchmarking plan. For BST with B-tree, I will conduct benchmark using a multiple datasets. I will measure search time for 1,000 or 5,000 or 10,000 cost records. The goal is show the difference in efficiency between two structures. Based on theory, BST worst case is 0 and while B-tree remains 0 log and consistently. These tests will provide quantitative proof of the improvement in solution 2. In solution 2, I will implement several enhancements. These include B-tree search instruction, advanced filtering option, improved admin interface, and response design, and the better dashboard for both admin and student. Overall, solution 2 will be more dynamic and scalable. Then, the system architecture comparison. This diagram compares solution 1 and solution 2. Solution 1 uses BST, which is simpler but less efficient for the larger data. Solution 2 uses B-tree, which ensures balanced search performance and smoother operations. The implementation time. I have divided my work into 3 phases, which is phase 1, focus on building and integrating the B-tree. Phase 2, update the user interface and improve the navigation. Phase 3 includes the performance benchmarking and evaluation. These roadmaps help me to stay organized and ensure timely completion. Next, the expected outcomes. I expect solution to deliver major improvement, faster and more consistent in search performance, better user experience, support for partial search, and this collaborative for large cost lists. These outcomes will make the system more practical and the real world use. To conclude solution 1, successfully demonstrate a fully working cost registration system using a binary search tree. However, BSC has a limitation that affect performance and usability. In solution 2, I will upgrade to a B-tree, enhance the UI, and provide a performance analysis to demonstrate the improvement clearly. Thank you. Thank you for watching.
And lastly, I will pass the presentation to Azrul.
Hi, my name is Azrul Firdaus Azmi. From Group 4, I'll be presenting on the student record system using the BST algorithm. So, a bit of introduction. For this project, we'll be using BST as well as abstract data type. I chose a C++ program, and I'll be using a CSV file storage system to persist the data. So this project will present an efficient and structured approach to managing the student's record by combining the BST, the ADT, as well as the CSV. Project overview. So there will objectives of this project is to design a student record system using the abstract data type, implement the BST-based storage, support the insert, delete, and display operation, which is search, and then persist the data storage using the CSV. The system design for the abstract data type interface, I've separated it into 4, which is one is the student ADT, the course ADT, and then the student course ADT, and the binary search tree ADT. This design enforces encapsulation, low coupling, and clear separations of concerns. The binary search tree stores data in a sorted order. The key for this will be the student ID and the course code. And the left subtree is always smaller than the actual node and is smaller than the right subtree. And there's no self-balancing or optimization used in this by designer. So the key functions for the student ADT, we have the student ID and the name. We have the function to get the ID to get the name, to set the ID to set the name, and check whether the search is valid, and to display the result. And key functions for the course, abstract data type, we have the course code and the course name. We have the get code, we have the get name, set the code and set the course name, and is valid to check whether the course data is valid, and to display, which is to print the course information in a list output. And then we have the student course abstract data type, which is the student course, which is the student ID and the course code that the user, the student enrolls. Then we have the get student ID, we have the get course code, we have the get composite key. Composite key is the student ID and the course code. And then it's valid to check whether the enrollment data is valid, and display, which prints out the list of the student enrolled courses. And furthermore, for the BST operations, here are the key functions for the public interface. We will be using the insert. We have the remove, we have the search, we have the get all sorted, and then we have a is empty function to check whether the tree has any elements, and clear, which is to remove all 3 elements. And then we have some private helper methods, which is insert node, delete node, search the node, min value node, which finds the node minimum value, and then in order, traverse, which is traverse tree in sorted order, destroy tree, recursively deletes all of the nodes, and extract key, which extracts the key from the data object. The data model is separated into 3 for easy storage management. So each student has a student ID and a student name. Each course has a student course code and a course name. And for the student courses is the list of the student enrolled courses, which consists from the student ID and the course code composite keys. For the file storage, we'll be using the CSV to persist the saved data in a CSV format. So the format for the student is student ID, student name. For the course would be course code and course name, and then for the student courses would be student ID and the course code. The data is automatically loaded at program start, and all records are saved before the programs terminate, and is in order and traverse features sorted output in the file, not in memory, just in the file. So here is a screenshot of the program execution. So for the program demonstration, this is the layout of the user interface. We're using command line interface. This is the main menu. So you select manage courses, manage student, and manage student courses. So right now I just want to show for the manage courses. 1 is to view all of the courses available, and then 2, add courses. So let's say MECS 1045 demo class 1 successfully added. And let's try and see if we can key in an already existing course. So just now was MECS 1045. Then let's try demo class 1. See, the course code already exists, so it will check whether the course code existed or not before inserting. If it doesn't exist, then it will create a new record, but if it already exists, it will not override. So now let's try removing the record, MECS 1045. Okay, the record has been successfully deleted. So see, there's no record inside. So let's try again, see if we can remove it again, MECS 1045. Record, the course could not be found because it's already been removed. So let's go back. Same applies with the managed students. View the students. This is the student. Same function, add and remove. Let's try and add Harith Iskandar bin Abdullah. Okay, so let's check. See, there we have ID 10011 Harith Iskandar bin Abdullah. And then let's try add a few more. Testing bin Subhajaya. So let's see. Now we have the testing bin Subhajaya. Okay, now let's try and remove a student. Let's try a random number. Let's see. The student is not found. Okay, now let's try again, but this time with a proper number 1011, which was testing this now. So deleted. Let's verify. Sorry, removed Haris Iskandar, which is 1011. The testing Subhajaya is 10012. Let's try and remove that. 3 10012. Okay, and let's see 1012. See, okay, it's gone. All right. Now let's manage on the student courses. So for this, we need to search the student ID. So let's try a random number, which does not exist. Okay, then let's try my ID, which is sorry. So back. 3. This is my student ID. Say Azrafida bin Azmi. So what is my registered courses? So this is my registered courses, information security system. So let's try and register a course. Let's try 104. Let me see, CS1045. This should not exist because, yeah, see, so we cannot register a non-existing record because this one was deleted before. So it checks and verifies that. Let's try register valid course, which is MECS on. Hang on, let me go back and see what other courses. 1, 2, TST 1234. Okay, let's take that one. TST 1234. So manage courses, student ID. Okay, let's register a course. TST 1234. Successfully enrolled. Now let's verify. TST 1234. So testing course 1 is already registered. And then let's see if I can drop a paper. Okay, successfully dropped. Okay. All right, seems to be working in order. So as you can see, I've also added execution time at the bottom of the results. For example, let me highlight this. So you can see here the BST execution time, 140 microseconds. So this one is just for benchmarking purposes, which can be showcased later. Okay. As a result from the execution, testing and verification, when we verified that the student insert was random, the searches for the existing and non-existing IDs seems to work. Reloading the data from the CSV file shows that the data is persisted, and testing edge cases such as empty files and single node trees, which returns the correct output. So all the tests seems to be correct and with expected result. Observation and findings. Key observation, BST is simple to implement, but slow in terms of performance, since there is no balancing and no optimization. Works better with random data. The abstract data type design simplifies code maintenance. Current searches are based on exact match. Persistent data did not affect the BST performance because the BST runs in memory and not in the file storage. This approach proved to be simple and effective and suitable for random data with no self-balancing and no optimization. For conclusion, the system successfully manages the student records efficiently if stored at random. The BST is simple to implement, but a bit slow in performance. In abstract data type principles ensure that the system design quality. Future improvements would be maybe to enable pattern match searches or regular expression searches, because currently the search is based on exact input and output. So maybe we can do like a instead of a full text, we put in partial text and it can return anything that resembles the search text. So for the best use case, when data is random, performance is usually good with simple implementation, which doesn't require any self-balancing and optimization. Thank you very much.
Thank you very much, everyone. Bye bye.